Have you ever come across code like this and thought, what's going on here? Why does it look like this? Why is this so weird and different from my normal code? If so, you're not alone. The first time that I saw a LINQ query, I kind of freaked out. In fact, I think it was probably about 10 years ago. I saw it and I thought, well, I'm never going to use that. That looks terrible. It looks confusing. It looks way too complicated. I'm going to stick with what I'm doing and just avoid that LINQ stuff completely. But it didn't take long before I started pulling in some of the easy bits. And after a short time, I decided why not dive in and try to figure out this whole LINQ thing. And I have to say that I'm extremely happy that I did because it saved me a ton of time and just a ton of pain over the years as a game developer. So if you're interested in saving time and saving yourself some pain, want to spend 5 minutes learning? Hang on with me. I'm going to run you through some of the fundamentals of LINQ, show you some really cool tricks and things that you can do with it, and even one thing that I actually just learned about it. But before we dive into the video, this video is sponsored by Backtrace. While alpha, beta, and playtesting in general is great, it's almost impossible to catch all of the errors and bugs that will, without a doubt, appear when developing a game. But with Backtrace, you can make sure all of these errors are caught before the release date and ensure a great and smooth user experience for your players. Backtrace offers an amazing plugin with support for all game engines, languages, and deployment platforms. They fully automate error capture, and their web console makes it extremely easy to monitor, analyze, and debug them across all platforms. Backtrace lets you capture errors in all instances of your game with a single system, and then generate structured, searchable error reports from your data. They also integrate with popular workflow tools, including Jira, Slack, and Discord. But the best thing about all of this is that their developer plan is completely free and lets you manage up to 25,000 monthly errors and gives you 10 gigs of storage. So get rid of all your game crashes right now for free by clicking the link in the description. Before we dive into why LINQ is so awesome and how you can use it in your actual projects, let's briefly just go over what LINQ is. If you look it up, it's short for Language Integrated Query, and it says that it's the name for a set of technologies based on the integration of query capabilities directly into the C# language. That might sound a little bit confusing and not make a lot of sense. In fact, that's kind of the thing that kind of put me off to it when I first started. I was like, I don't know what any of that means. And then it starts to talk about SQL and XML and LINQ to SQL and reading SQL data. And that's what it was originally kind of set up for, was to read data from a database, query it, and put that into your code and do stuff with it. Those queries were often written in the query expression format, which is a little bit different from normal C#. In fact, it's different from what we're going to use completely. It looks a lot like SQL. And if you're familiar with SQL, you're a database administrator, it was an easy way to kind of translate your code right into something that worked into C# or translate your SQL into that. We're game developers, so we don't really need that. Instead, what we care about is the enumerable class and the LINQ extension methods that are available with it. You're going to see just how much power we have there when we expand out the methods here. Scrolling through, you can see all of these different options. I'm going to show you what most of the important ones mean, how you can use them in your project, how they'll save you some time, and then at the end, give you some advice on how to avoid them causing you any problems. So make sure that you hang around for the end so you don't miss that, I'd say, very important part. To demonstrate how to use LINQ statements, I've set up a little example. You can download the example down below. Just click on whatever link is down there to get to the example, and you can go check it out yourself. But I'm going to run you through what the code means, and then we'll dive into the actual LINQ examples. The first thing we're going to look at is the Npc class. It's a really simple mono behavior, just a component we could drop onto any game object and then use as a prefab. In the examples here, we'll mostly be thinking of scenarios where we've got maybe a set of NPC prefabs, but we could also be working with a set of spawned NPCs for NPCs that are alive and running around. In fact, we'll even do some queries on the health. So we've got NPCs. NPCs have stats that are serializable. We've got some damage, attack, range, strength, and wisdom. We use maybe one or two of those. And then we've got factions so that we can separate these out into different groups using some of the cool LINQ functionality. Let's dive into some examples and start with the first one. The first example that we're going to use is the any statement. So in LINQ, we can use .any at the end of any collection here to check to see if anything in the collection meets the condition here. So let's talk a little bit about LINQ statements and how they're structured. We're going to zoom in quite a bit here, and we're just going to take a peek at this part right here. Right now, our LINQ query is split into 2 lines. I'm going to go up 1 line and just delete that out so that we get it into a single line and we can read it really quickly together. So let's see what this LINQ query looks like. We take our collection here, which could be an array, it could be a list, it could be anything that implements IEnumerable. Let me show you, we can change this over to list of NPC. It's going to work exactly the same. It'll work as an array though, so I'm going to switch it back with undo. So we take our collection and we use the .any method. Now to get this .any method, we need to have the using system.link statement in here. If I don't have that, you're going to see that I've got all kinds of errors and that disappears, but I can just hit Alt Enter and then add the statement automatically. That's one of the nice things in Writer and Visual Studio to pop up. You hit Enter one more time and it'll automatically add. Just make sure that you have using system.link at the top and you'll be able to use this method. So what is this method doing? Let's take a look at it. The .any method is going to do this or check this predicate right here against every entry in our collection or every element in our collection. T is going to represent each element, so it's going to iterate through each element of our collection and tell us whether or not T or that element of its faction is an elf. If that's true, if any one of them is true, so if the first one is true, it's going to return back true. If the first one's not true, it's going to continue on, go to the next one, continue on, go to the next one, continue on until it finds one that is an elf. If none of them have their faction type set to an elf, eventually it'll reach the end of the collection of NPCs and return back a false. This is just an easy way to check to see if anything in a collection matches some condition. Right now we're only checking to see one thing, but we could also do an AND statement here. Maybe we want to see if we have at least one elf with a big ranged attack range. So we could add 2 ampersands here right after the elf inside the parentheses and say t.stats.attack range is greater than 10. So here we'd be checking to see has at least one elf with 10 attack range. Now here I would probably split up my statement into multiple lines, make it a little bit easier to read, including right after the ampersands. I'll just put that down onto a new line and then fix up my return statement there. And we'd have a statement that checks to see if we have one elf with at least 10 attack range. Now that's probably not the most useful combination of things to query in there, but I'm sure you can imagine lots of other useful things like NPCs that are close to you or alive or on the other team and alive and aggro or any other way that you might want to filter to see if there's anything matching that. Let's go on to another example though. Let's talk about some averages. Here we've got an example that shows the average strength of our orcs. We can use npcs.average, pass in the selector again, and in the selector we'll use the thing that we want to select, which is going to be our strength int. Notice that the return type here though is not an int. Because we're taking a bunch of integers and we're averaging them out, we're not going to want an integer because that won't be very accurate as an average. Our average needs to be whatever's in between. If we had a 2 and a 1, we'd want a 1.5. Not some number that's either 1 or 2 somewhat randomly. So we do get back a double, and it's a pretty easy way to just average out things. So if you've got a big long list of numbers or just a big collection of things that you want to get the average of, you can just use average. Pretty simple. Let's look at the average where we're filtered though. Here we're doing an average statement, but we're using the where clause. Let's separate out the 2 LINQ statements onto their own line and take a peek at it. So we're looking at average orc strength by going through all of the NPCs, filtering them down with the where statement, which is a very, very important one, and it's probably the most powerful and the one that I use the most often. A where statement filters down this list based on the predicate here. So we've got our selector here of T, which is going to be each NPC. It's going to check for every NPC that is an orc, and then it's going to filter it down to just those, and then give us the average of their strength. So here we'll get back the average orc strength. Pretty nice and pretty useful. You can start to see how we can put together some of these queries and combine them to make more powerful statements that don't require very much code. Let's go on to the next one, the sum of total health remaining. So if you want to get an average, it's average. If you want to get a sum, it's literally just sum. Here we've got a statement that gets us back the remaining health of all of our NPCs. That's of course assuming that this is no longer a list of NPC prefabs, but maybe a list of spawned NPCs. We get a sum of their total health, we get a sum of their total scores, a sum of the total armor on all of their vehicles, whatever the thing is that you want to sum up, you just use the sum statement. Let's go on to the count one. Now count is a little bit interesting. So if you've used count before on lists, you know that it just returns back the number of items in there. And that's not using the LINQ statement. That's just getting you back the size of the collection or the number of elements in the collection. What count does in a LINQ syntax is allow you to get the number of elements matching a predicate. So here you can see we've got the number of humans by counting the NPCs using npcs.count and just giving it a faction check predicate against our selector. I do want to point out that I don't often use the count method. Most of the time it's because I want to pull these things into their own collections, and then I just get the count of them. So if I wanted to find all of the NPCs, I might do one of the other statements that we'll get into later to put them into their own collection and then get the count of them. There are some cases, though, where I just need the count of a thing filtered down, and I don't want to grab a whole new collection of them, and this comes in handy for that. Now, before we go any further, I do want to mention that I've been using dark mode for this video, and if that's something that you actually like, please comment down below and let me know, and if you hate it, let me know too. I don't particularly have any love for it, but I know a lot of people like it, so if it's something that everybody wants me to keep doing, I'll do it. Otherwise, I might switch back, so just if it's important to you, let me know. Let's dive on to the distinct example now. The distinct word here, or the distinct keyword or extension method, will filter out entries that are duplicates and return back a collection of things that has only unique or distinct items in it. You can see in my example here, we create a new list of NPCs, we create a single new NPC, and we add it to the list twice. To make that list distinct or no longer have duplicates, we can just use the .distinct method in it. Now, distinct method returns back an IEnumerable, and I thought that was kind of important to note because if you have an IEnumerable and you happen to want to turn it back into a list, the toList method is the one that you want to use. That's actually the first one that I started using in LINQ. It's the thing that kind of got me converted. I was like, oh, I can just use this to convert an array over. And then I realized I could start converting to all kinds of other things, not just lists. We're going to dive into those shortly, though. Let's move on to the first or default example. First or default is probably the second most used one for me. Might even be the most used outside of where. I'm not sure. They're probably right around equal. But the first or default method allows you to find the first or null or none item out of a list matching a predicate. It's a good way to search a list for a specific entry, or if you really just want the first entry, any old entry from a list, it's a good way to find that as well. Usually when I'm using first or default, though, it's to find a specific entry. I want to find something by a name, by a health, or an ID, or something else like that. Here, I've got an example set up where we're finding the first dead NPC. And if we find nothing at all, we'll get back null. It'll say no NPCs are dead. If we do find one, though, it's going to say that the first dead NPC, the one that we got back, is the first entry in the list that's dead. I want to be real clear that this is not the first NPC that died. This is just the first one in order in that array that has its health less than or equal to 0. So that's what you're getting with first or default. You're getting them in the order that they come in, the first one that matches that predicate. Let's look at the first keyword, though, and see what's different here. In this example, our line 90 here, where we check to see if the first dead NPC is null, won't work. If we don't have anything that matches the predicate here, it'll actually throw an exception. Now, you might think that's kind of not very handy, not very useful, and I tend to agree most of the time. There are very few cases where I actually use the first keyword, but there are some scenarios where you might want to just throw an exception and not handle it if the entry isn't there. Most of the time, though, you want to handle those exceptions and deal with it yourself, at least when you're building out your game code. Now we're going to get into some magic and start using the order by keyword or the order by extension. This is one of my favorites. The first one we'll look at is ordering by name. I've got a list of NPCs, and here we've just ordered them by name. They'll go in alphabetically, assuming that t.name is the game object's name or the prefab name. Remember, t is an NPC. Name on a component gets us back the game object's name, so this would be whatever that prefab or the instantiated NPC's name is, whichever way we're using this NPC list. So this will order them by name and return us back a list or a new ordered enumerable collection. To make it into an actual list, we could just say .toList at the end and get it back as a list if we needed it as an actual list. But what if we wanted them in the opposite order, from Z to A, or maybe we want to go from high numbers to low numbers? In that case, we can use the order by descending. Order by descending just goes in reverse order of order by. Instead of going from low numbers to high, it goes from high to low. And instead of going from A to Z, it goes from Z to A. Now we're going to get into the most exciting and one of the coolest order bys, ordering by a random number. So when we use the order by, we're giving it a selector, and we don't have to necessarily use that selector. We can use anything that we want. Here you'll see that we take T and we completely ignore it and then just use a random range from 0 to 100. This is going to randomize the order for every entry. It's just going to roll from 0 to 100 and then order them by whatever they rolled. This is a really neat trick and a really easy way to randomly order your objects. If you have a large number of objects, more than maybe 100, you probably want to go with a larger number than this. And there's nothing limiting you. There's no reason that you couldn't use min int and max int or min float and max float or whatever you want in here. Now we're going to dive into some more complex statements like the group by one. In the group by statement, we get back an I grouping based on whatever the selector is that we pass in. Here we're passing in a faction as the selector, so we'll get back 4 groups, 1 for each of our factions, assuming that we have an entry of each faction in our list or our array of NPCs. And then we loop through that grouping, and you'll see that we'd get a log entry for each faction, and then underneath each faction, we would get a log entry for every one of its NPCs. The group by on its own isn't something that I use often, but I do use it in conjunction with some other extensions that you'll see in just a moment. Let's take a look at the next one, which is Intersect. Intersect is an interesting one that I don't often use, but I thought was kind of useful to cover. Intersect allows you to take multiple collections. So here I've got just 2 enumerables of NPCs who are elves, and NPCs who have no health. And then you can intersect them and get the combination or the things that are in both of those lists. So if we have NPCs that happen to have no health, they'd be in both of these lists, and we'd be able to get those back as this new collection of NPCs who are in both collections. Now, since these are both coming from the same source, it doesn't make a whole lot of sense. It'd be better to just have a where statement with an and just do the query at that time instead of getting 2 separate collections back and intersecting them. But there are plenty of situations where you get 2 separate lists or 2 separate collections from different sources, and you need to combine them and see what matches or what intersects between them, and the intersect keyword will do that for you. These next 2 are actually really simple and just kind of a break from the more complex stuff that we're diving into, and that's min and max. Min and max just return back the minimum value and the maximum value from a set. So here we can get back the minimum strength value or the maximum strength of all of our NPCs. Pretty useful when we have a big collection of stuff and we just want to find the outliers or the things on the edge. Now let's move on to our select example, and select is really powerful. Select allows you to transform the data that you're getting back and get something other than what it is you're actually querying. So we don't have to get back a collection of NPCs. In this case, we could get back just a collection or an IEnumerable of factions. Here we're looking at all of the active factions, or getting back the active factions, by filtering NPCs where they have health greater than 0, so only things that are alive, and then selecting their faction. The dot select here on the next line is just a continuation of our LINQ statement. Is going to just make it so that we return back the faction here of this selector, so t dot faction, and then we'll get those back as the collection and return them. Now we don't necessarily have to do factions. It could theoretically be anything. We could just return back all of the stats object and then have this be stats instead and get back all of the stats of all of our NPCs. We wouldn't have the NPC references to them, might not be useful, but if we had a stats processor that just needed all of the stats, hey, maybe that's a way that we could use it. Let's undo that real quick though and just continue on to our next example. Say we wanted to get distinct factions. What do I mean by that? Well, I mean that in this example here, our factions include duplicates. So for every NPC here, we're going to get back an entry of a faction. If we wanted to get back only the factions that still have an NPC alive, we could get back the distinct ones. So we could say the same exact statement, NPCs where health is greater than 0, select the faction, dot distinct, and suddenly we've got up to 4, or 0 if they're all dead. This next example requires a little extra code. Here we've got a page number field and a method to get the next page of NPCs. This is the type of LINQ statement that you might use in a paged UI or a couple other scenarios, but paged UIs are kind of the number one thing that popped to mind. So here we have a page size set to 10, and then we get back a list or a page of NPCs by using the skip method and the take method. So we're using two different LINQ statements here. We're using skip to skip over some number of entries. The first time through, this will be 0 entries, so we'll skip 0 entries, and we will take 10 entries. The take method is just going to select that many entries, or up to that many. So if we have more than 10 NPCs, we'll get the first 10 NPCs. If we have 5 in there, we'll get those 5, and that's it. Now, the second time we run this, because we'll be incrementing page number here on, what is this, line 170 now. The second time we run through, it will skip the first 10 entries, because it'll be 10 times 1, and it'll take entries 11 through 20 and return those back out. This is extremely handy if you're ever building any kind of UI where you need to make pages and tab through things, or if you just need to select things in groups and process them in groups. You want to process 20 NPCs at a time, you can use the take method, get those 20 and do some processing on them. Here's another quick, easy one before we dive into the final and most complicated and I think most fun ones. Here we've got a simple conversion to a list and then maybe back to an array. We can also convert over to a hash set or a queue or pretty much any type of collection that we want. The next one, though, is the best, which is one that I cover in my game architecture course. If you're interested in that, make sure that you check that out down below as well. And that one is toDictionary. toDictionary allows us to convert any of our IEnumerables over to a dictionary with a key value lookup. And the way that I really love to do it is to take a collection of objects, group them using the group by. So you can see right here on line 189, we're grouping by the faction and then selecting V as the value. So I use V as a keyword here for value and K as a keyword here for key. It's just, you can use whatever you want in these Lambda selectors. I could use the same thing. I could use T, use T1, T2, whatever it is. I like K and V. They're very common standards here when we're using a key and value. So we group them by the faction, select the objects, and that gives us back the I grouping. From that, we take the dictionary and we use the dictionary's key, and then we use toList on the grouping. So this gives us back a list of objects. Let's go back here and look at the type again. We have a list of NPCs for each faction. So now we can look at each faction, see all of the NPCs in that faction, and then use that whenever we want. Now, why would we do this? Why would we put this into a dictionary? We probably wouldn't do it if we were just going to throw this dictionary away. This is usually the kind of thing that I would do when I'm going to cache the object. I'll keep this NPCs by faction around, maybe keep it as a field, and then use that somewhere, maybe when I want to loop through all of the NPCs of a specific faction. And I don't want to do the query over and over and over because there are some performance hits there. We're going to talk about those in 1 second. First, I want to show you really quickly the one entry or the one LINQ statement that I didn't realize existed. I totally missed. I think I probably learned it a long time ago and completely forgot about it. And that's the lookup. toLookup does something very similar to what toDictionary does. The toDictionary is giving us a collection here for each faction that we can iterate over and do something with. toLookup does the exact same thing with a little bit less code, but we don't have a dictionary. We don't have an object here with a list of objects that we can add to, modify, and change. We can't add to this later on. So if we want to have an immutable object, an immutable lookup object of all of my entries here, the toLookup option may be better. So a scenario for this would be perhaps prefabs. The prefabs aren't changing at runtime. We might want to make a lookup of them so that they can't be changed later on. Something that's runtime, like NPCs that are alive, I'd go with the dictionaries option instead. So why would you even want to cache these if you can just write a query like this? If you can just write this LINQ statement and get the data, what's the point of putting it into a dictionary and saving it off, or putting it into a lookup and saving it off? It's a really good question and an important thing to cover. The issue here is that LINQ statements, while they are fast and performant generally and extremely powerful, they do generate a little bit of garbage. And by that, I mean that they allocate a little bit of memory that the garbage collector needs to clean up later. If you're building a mobile game or a VR game or a console game, this can be an issue, especially if it's in your hot path. And the hot path of your code is essentially code that's run all of the time, something that's maybe in an update, in a fixed update, or just regularly running extremely often. If it's generating a bunch of allocations like that and then needing to clean it up, it can cause some stuttering. So you want to make sure that when you're using LINQ statements, you use them in a way that they're not firing off all of the time and you cache the data whenever possible. If we want to do a big selection of data from a collection, we should select it and save it off somewhere if we can, if we're going to use that data again. Like any code or library or package that you might pull in, there's always the opportunity to do things wrong and cause bad performance problems. But in general, I would say that LINQ is relatively safe if you're careful with it and you just profile and watch what you're doing. Make sure you don't do any crazy statements in your updates, or just try to avoid linking updates and move them to on enable starts and awakes, and you'll probably be fine. I hope this was helpful, and I hope this is somewhat useful to you. I know that, again, link statements kind of terrified me for the first many, many years. So I wanted to try to demystify them a bit and make them a little bit simpler for everybody to understand. So if you like it, make sure that you hit the like button, subscribe, and I'll do more of these slightly in-depth videos. Also, again, if you have thoughts on the dark mode, let me know. I'm curious. What does everybody think? Does everybody hate it? Do they all love it? Is it something I should stick with? Is it going to suddenly make my videos the most popular thing ever? I don't know. I guess we'll find out. All right. Thanks again. Also, don't forget to check out Backtrace. Get started automating your debugging and crash analysis workflow completely for free by simply clicking the link in the description.